Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's lesson, we will discuss about the effect of temperature and pressure on the density of an gas. So, first of all, we have to have a look on the ideal gas density formula. So, the formula of density we have density D is equal to mass or the molar mass into pressure divided by the product of general gas constant and the temperature. So in what unit we are going to calculate the density? Basically, ideal gas density is in kilogram per liter and the molar mass is in gram per mole. Pressure is in atm and R, which is the general gas constant or the molar gas constant, its value we will take it 8.31 joule. And the temperature we will take it is absolute temperature that's in Kelvin scale and its value is 273.16 Kelvin, which is known as the absolute zero temperature. So absolute zero temperature and the values of the molar mass, pressure, R and T. We will calculate the density of the gases. So we will use this formula for this purpose. Let's have a look on the change of the density. From this formula, we have just seen that density is directly proportional to the molar mass. Density is directly proportional to the pressure. If both molar mass and the pressure are going to be increased, then in turn the density also increases. But on the other hand, the density is inversely proportional to the temperature. When temperature increases, then density will be decreases. So there is a inverse relation between density and temperature. So let's have a look by simple calculations that how the density is affected by the temperature and pressure. So first of all, we will calculate the density at 27 degrees Celsius. Here, the temperature we have, it is 27 degrees Celsius. By adding 273.16 Kelvin, we will calculate it as 300 Kelvin, or the temperature will be in Kelvin scale. Now we will put the values of density, general gas constant and the pressure. The equation we have D is equal to Pm over R into T. So here the pressure we have, it is the general that D is equal to pressure is 1 atm, multiply it with the molar mass. For example, here the gas we have simple, it is 16 divided by, it is in gram per mole. 1 atmospheric and general gas constant R we have 0.0821 and its unit we will take it is dm cube atm per Kelvin and per mole. Multiply it with the temperature, which is 300 Kelvin. Now what will be the answer for this calculation? Density will be 0.649 gram per dm cube. So this is the main density that this gas covers at 27 degree Celsius. But before that, if we have the comparison of this and the temperature we were having 0 degree Celsius, then what will be the effect on the density of the gas? So if we take just 0 degrees Celsius in place of 27 degrees Celsius, then by doing this calculation, in this way we'll put 273 and the answer will be 0.7138 gram per dm cube. So this is the density at 0 degrees Celsius and this is the density at 27 degrees Celsius. So you guys can have a comparison between these two densities as When we increase the temperature, the density decreases. But on the other hand, when the temperature was high, the density was also going to be decreased. It's mean there is an inverse relation, or under the given conditions, the density of gases also changes by applying the different conditions of temperature and pressure on them. After that, we have when density at 2 atmospheric pressure and 0 degrees Celsius. Now we are going to change the pressure. So the same equation we have, which is D is equal to Pm over R into T. So here the pressure we have, it is 2 atm, and the molar mass, the gas that we are going to use over there, it is methane, which is CH4, as its molar mass is 16 gram per mole. Pressure is 2 atm, molar mass is 16 gram per mole. General gas constant R, we have same 0.0821 dm cube atm per Kelvin per mole. And the value of temperature here we have 0 degrees Celsius. By adding 273, it is 273 Kelvin. Now we will put up the values. So the density is equal to pressure we have 2 atm, multiply it with the molar mass, which is 16 gram per mole, and divided it with general gas constant, which is 0.0821 dm cube, and the units atm per Kelvin per mole, multiply with 273, that is temperature, and the answer is 1.427 gram per dm cube. So when the pressure increases, the density also increases. It means there is a direct relation between pressure and the density of the gas. So when both these are changes, the conditions and all the values are also going to be changed, because the density of the gas, when we apply the condition where pressure was 1 atm, so the density was just 0.649, but when the pressure is 2 atm, now the density is 1.427 gram per mole. It's when we are going to increase the pressure, then the density also increases. And the next topic that we will discuss, it is the Avogadro's law. So we will find that what the Avogadro's law tells us about the volume and the pressure and the temperature of the gases when all these conditions are changes. For that time, you guys have a good day and Allah Hafiz.